Hello everyone. In this video session, I will be discussing about the spin-spin coupling or splitting of the signal. So what is spin-spin coupling? So the number of signal in a proton NMR spectrum is equal to the number of kind of protons present in the molecules. For example, if we see the spectrum of for ethyl acetate, it has 3 peaks where only one is singlet and other two are multiplet. Means this is giving 4 peak, that's why we said quadruplet. This is giving 3 peak, we say triplet. And this is called the splitting of NMR signal or the spin-spin coupling. Like instead of singlet, you are getting a multiplet, means quadruplet, triplet or doublet. They will be splitting of the signal. But why spin-spin coupling is observed? This is due to interaction with the nearby protons. Let's see the example of diaminopyrimidine, which has two protons Ha and Hb beside the amino proton, which we are not discussing here. We will just discuss about Ha and Hb protons. So Ha and Hb protons are giving singlet in the NMR spectrum because they are far away from each other and they are not interacting with each other. So that's why they are giving only singlet. But if we see the spectrum of cytosine, which has Ha and Hb, two protons, close enough to experience the small magnetic field of each other. Like Ha will feel the magnetic field of Hb and Hb will feel the magnetic field of Ha. So Ha will interact with Hb and it will split the signal of Hb into doublet and Hb will split the signal of Ha into doublet. So in cytosine we are getting two signal of doublet and doublet. Now what is the principle of spin-spin coupling? So let's take the example of two proton Ha and Hb. So in first case, if there is no interaction between Ha and Hb, then each proton will interact with the applied field only. So there will be only two singlet. But if Ha and Hb interact with each other, so first case where the field of Hb is aligned with the applied field. In case Ha will experience more field because the field of Hb will be added to the applied magnetic field. So the Ha will experience more magnetic field and the gap between two energy states of Ha will slightly increase. So that will slightly move the peak of Ha to downfield. In another case, the Hb can be in opposite direction of the applied field. In this case, the field experienced by the Ha will be the applied field minus the magnetic field of Hb. In this case, the chemical shift for Ha will be slightly decreasing. So finally, Ha will be appear or will be visible as a doublet because there is a slight magnetic field generated by Hb, so there will be very small difference between these two peaks of doublet. So the energy required for resonance depends on the field experienced by the proton. So these two situations gives rise to slightly different peaks like a doublet, and whatever happens to Ha, that will be happen to Hb also. So as well, so the spectrum has two doublets, one for each proton will be observed. So each proton will couple with other and the field of proton is very small indeed in comparison with the field of the magnet. That's why the separation between this line of a doublet is very small. So now the spin-spin splitting is observed only between chemically non-equivalent proton. Equivalent proton do not couple with each other and splitting will not be observed. So we can calculate the number of peaks in a multiplet by n+1 rule, where n is the number of protons responsible for splitting or number of chemically equivalent protons. So let's take the example of this chloroethane. So the 3 methyl group are equivalent, but they are non-equivalent to the CH2 proton. So these CH2 proton will split the peak of CH3 proton, and according to n+1 rule, this CH3 will be splitted into the triplet due to the CH2 protons, and the peaks of CH2 proton will be splitted into the quadruplet due to the CH3 protons if we apply the n+1 rule. So on the other and the protons of both the methyl groups, all the 6 protons in ethane, that is CH3 are equivalent, and they do not split the signals, and all the 6 protons appear as a single peak. So first we have to find the chemically equivalent and chemically non-equivalent proton. Only chemically non-equivalent proton split the peaks to each other. So in general, the spin-spin coupling is observable up to 3 bond, unless some special cases such as small ring coupling in aromatic, etc. So we will mainly discuss the coupling up to 3 bond only. So now if we come back on the spectra of ethyl acetate, we see this is quartet, this is triplet, but the intensity of the peak also different. In case of quartet, the intensity is lower than the triplet. So why this intensity is different for each multiplet? So let's see this probability method. So here CH and this CH are coupling with each other. So if we see this CH, we'll see to this proton in two ways. Like this will oppose the applied magnetic field, or this will be aligned with the applied magnetic field. So there will be only two possibilities. Like it will opposing the applied field, it will aligning the applied field. So in this case, we will get only 1:1 ratio for the peaks in a doublet. If there's a 2 protons, now these 2 protons will split this rad protons into triplet. So there will be 3 peaks. How we will get the intensity for this? If we see these 2 protons can be either in the opposite direction or on the same direction. But one proton can be in same direction and one proton can be in opposite direction. Now it will be same, which was the in opposite, that will be now in same direction, which was the in same direction, that will be now in opposite direction. So for this case, there is a two probability. So total there will be ratio 1:2:1 for a triplet. In case of 3 proton, there will be quartet. So if we see this 3 proton either can be in the same direction or in the opposite direction. Now this will be the 3 cases for these two probabilities. So now we will get a 1:3:3:1 ratio for a quartet. So every time we cannot do this probability method, so we have to use this Pascal triangle to get the intensity of multiplet. If there is a doublet, the intensity for peaks will be 1:1. If there is a triplet, the intensity will be 1:2:1. If there is a quartet, that will be 1:3:3:1. If there is a quintet, that will be 1:5:6:4:1, as so on. And in general, if it's more than 7, we generally say is multiplet. So thank you very much and have a nice day.